In this video, we are going to go through examples of the reactions of alkenes in our first video that we did. Now, before we start with the examples, let's look at some simple example that I have done here. Now, we are having this particular compound, of which I think we can name it. We have position 1 and 2, and then this one is an ethyl, and then it's a cyclohexene. So it's an ethyl cyclohexene because there is a double bond there. Okay, so we are having an ethyl cyclohexene that is reacting with H2 in the presence of palladium or platinum. So from the videos that we watch over here, we are going to add 2 hydrogens to it, and then the 2 hydrogens will be on the same side. So you can see that the first hydrogen has been added to the first carbon, and the second one has also been added to the second carbon. That's all that you need to know. We have various mechanisms to it. Now, it forms a sign addition, so you can either make both wedge or you can make both of them dash. When I mean wedge, this is the wedge, and then that is the dash. So this is the dash, and then that's the wedge. Okay, and then over here to addition of chlorine, we have Cl2 reacting with our compound. You can see that 2 chlorines will be added, one on this side and the other on this side, but they are anti. In other words, they are not on the same side, they are anti-addition. We are going to add 1 chlorine, of which one will be a dash and then the other one will be a wedge. Now, let's begin with our examples that we have. The first one that we are having is this compound. Let's try and see whether we can do this reaction. Okay, let's continue. So we have oxone here in the presence of zinc and an H3O, or an acid. That's ozonolysis. And then what happens is that in the presence of ozonolysis, there is going to be an oxidative cleavage. This is going to break like that. So we are going to have something like this, with both being broken like this. Then oxygen will come and fill these places. This is what we have for our compound when it reacts with this. So we can also draw it in a different way to see we're having 1, 2, 3. So it can be like this: 1, 2, 3. Then so this, you can do this or that. Okay, now we have this one too. That's a diiodomethane reacting with we have 1, 2, 3. 1, 2, 3. That's a propene. So a propene, we are going to react it with this. We are going to form a cyclo. Always when you see this reagent, remember it forms a cyclopropane. So on the 2 carbons that are these 2 carbons that contains the double bond, we are going to form a cyclopropane like that. So this is what we are going to get, or you can draw it like this. Okay, so this is a different compound. This is a methyl cyclopropane. Now we have this one to KMnO4 in an acid. That's an acidic potassium permanganate. What we are going to do is that since this one is more of a stable one, it will react with the alkene that we are having. Mostly when you have a compound and then we are being given a reagent, let's look at specifically where it reacts with and then move on straight. Now it reacts with this. Since it's in an acidic medium, there is going to be a cleavage. It's going to break here. Now when it breaks, we are going to get our benzene here containing our double bond, and then this one has also been broken. Oxygen will be filled here, but there is an H here, an H. The H will be changed to an OH. The H will be changed to an OH, and then also this is a terminal alkene. So if you remember in our previous videos, a terminal alkene will give us a carbon dioxide. So this is what we are having. This can also be written as CO2. Now the next example that we are having, when we are having 1 2 3 4 5, and then on the second position we have a metal. So a metal 1 2 3 4 5. So a metal paint, a metal paint, a metal paint 2 in, since the double bond is on the second carbon. Metal paint 2 in. Now with this, when we are reacting it with an HOBr, this one is halohydrate, where we are going to add an OH and then a Br. So when we are adding an OH and a Br, we draw our compound. How will we add it? So first the Br will act as an H. So the Br will first go in so that the OH will be formed on the most stable side. So the Br can't go here, because when it goes here, the carbocation that will be formed here will be a secondary carbocation. So it needs to form here. The Br needs to form here so that the carbocation formed here will be a tertiary carbocation for the OH to come here, just like this. So this is the compound that we are getting. Now we also have the second reaction, where we are reacting H plus, the presence of water, with cyclohexene. Here too we are going to add an H. Let's not forget, first thing that you have to note, what are we going to add to the double bond? We add an H and a what? An OH. So we are going to get this reaction, this compound, where we add H and an OH. Or you can also do it the vice versa. You can bring the H here and then bring the OH here, because it's symmetrical. Okay, now we have the last reaction, where we are reacting KMnO4 in a base. So KMnO4 in a base, or KMnO4 in OH water. What happens is that this is an alkaline KMnO4. So we are just going to add a diol in a sign addition. So what happens, we draw our compound, then we add our 2 OH. But this, it can be both dash, or you can make it wedge. You can make both of them wedge. Okay, now our next example that we are having, let's look at it carefully and see whether we can do the reaction. Okay, now in this first reaction, we are having this compound reacting with this. All that I need to do is that look at where the compound is going to react and then what the compound does. So this osmium adds 2 OH. It adds 2 OH. In other words, osmium mostly form a diol. So we are going to add a diol to the 2 carbons. How does it go? We draw our compound like this. Then the 2 carbons are over here. So we are going to add 2 OH, which should be in the same side. So we can make it both wedge or both dash. All that needs to be formed is that it has to be on the same side. So this is notifying us that they are on the same side. Now we also have this last example also, where we have a 1 2 3. We have a propene reacting with this hydrogenation reaction. So we are going to add 2 hydrogens to the propene. What we get is this is already there, that's already there, and this already there. So we bring our new hydrogens, which are formed on the same side. So this is what we are getting for a propene reacting with hydrogen in the presence of platinum. That's a hydrogenation reaction. Now we have this last example here, of which the examples that you can be getting, or the compounds that you can be getting, you can do a retrosynthesis, where we'll be given the product, then you'll be asked to work backwards. Let's try this example. So when we look at it carefully, in our first reaction we are forming this. How can we go back? Now we can see that we are having a certain cyclopropane formed over. Our compound can then be this. You first have to propose or get some information in your mind that there should be a double bond somewhere, of which a certain compound can react with it, of which we will get this cyclopropane on top. So can we get something like that? Yes, I think this is possible. This is a possible structure that we can get, where when we react it with a diiodo, when we react it with a diiodomethane in the presence of a zinc copper in ether, we are going to form this cycle on top. That's the same thing that we have gotten here. Now the second one. So with the second one too, we can see a chair being drawn here. A chair structure of a cyclohexane being drawn here, and then there are two oxygens on it. Sorry, there are two OH on it. That's a diol. But from what we are seeing, the OH are on the same side. They are all pointing downwards. And then they are on two adjacent carbons. What can we guess? We can guess that then there should be a reagent that will give us, there should be a double bond somewhere. Say this our chair. There should be a double bond somewhere. The ether is there already. Yes, it should be like this. There should be a double bond. There somewhere where we are going to react it with. It can be either we can react it with any of these two. It's either we react it with KMNO4 in a base, that's OH water, or we can react it with osmium. Like we did for the other ones, in the presence of NaHSO4 in water. So we can react it with osmium, also NaHSO4 in water. Yes, we can react it with these two. Then we get our product adding to OH to our double bond. Thank you very much for watching this video.